So the 3-4 investigation is about composition of functions. So it's just kind of a new concept of how these functions are going to work together. Now, all a composition of functions is you're going to start with one function, you're going to work your way out to a second function, sometimes even a third function. So I always think where we're going to work ourselves from the inside to the outside. Okay, so let's look at our first problem. It says, running is a popular form of exercise to burn calories and stay healthy. The number of calories burned while running depends on many factors, but averages about 110 calories per mile. Suppose that Mila goes for a run, traveling at a constant speed of 0.15 miles per minute, while burning approximately 110 calories per mile. The first thing says, how many calories does Mila burn if she runs for 40 minutes? Okay, so let's think about the process we have to go through. First off, we need to know how many miles she went, right? Okay, so we know that distance equals rate times time. Her rate is 0.15 miles per minute. So that gives us that her distance is 0.15 t. So that's the function for her distance. And then I've written it over here so that you can kind of see it in a more of a function notation, okay? So if she runs for 40 minutes, if we do 0.15 times 40, we get that she has run 6 miles. Now, the question didn't ask us how many miles did she run. The question asked us how many calories did she burn if she runs for 40 minutes. So we started with minutes. Right now, I've got miles. And now I need to know, what do we know about miles? Well, it says that the calories burnt is 110 calories per mile. So then I made up this equation right here. That if I know the distance, so I'll make that D, that if I just take 110 times that distance, if the distance is in miles, I get calories. So then we're going to calories. So I know it's 6 miles. So the calories is just going to be 110 times 6, or 660 calories. So you'll notice this was a two-step process. I started with the information about distances, rate times time. I started with minutes. I converted that to miles, and then the miles became calories. So that's going to lead us now to B, okay? So I'm going to write it a little differently this time. I'm going to write that we need to find the calories, and we're going to plug in a distance that started out with a time. Do you see how we've kind of layered it now? So if we use that notation instead, this two-step process will be contained within it. So let me show you what I mean. We're going to ignore the outer thing, and we're going to find the distance she runs if she's gone 34 minutes. Well, I know that the distance formula for this one is 0.15 t. So I know that that's going to just be 0.15 times 34, which is 5.1 miles. You'll notice I have not touched the calorie information. Do you see how I worked from the inside out? What is the distance for a 34-minute run? 5.1 miles. Now I can implement the calorie formula. So this is going to just be 110 times 5.1. That is 561 calories. So what function composition tells us is that we're going to work our way from the inside out, okay? So what they're saying in part C is, what is C of dt? So let's plug our d of t function in. Remember, our d of t function was 0.15t. And if we plug that into our calorie function, that's 110 times 0.15t. So we worked our way from the inside out. So let's write some notational stuff down so that you'll know it, okay? So this is a common way that you're going to see function composition written. Sometimes they will even put this little, an open little circle. That does not mean multiplication, that means composition. You need to know that these two notations mean the exact same thing. So if they switch it, if they write this, the inside function always comes after the little open circle. Please, please note this somewhere in your notes. This notation is super important. The inside function always comes after the little open circle. The inside function always comes after the open circle. We always work our way from the inside out. So even though we're so used to going from left to right, this tells me I start with the g function, get something, and then go to the f function. This one, I start with the f function, then I go with the g function. So it's important to know how that works. Now, in D, it says, define a function f that represents the distance in miles that she has run, D, in terms of the minutes. We already did that. F of t was 0.15t. I think I was working a step ahead of them. And then E says, define a function G that represents the miles that, or I'm sorry, the number of calories she's burned in terms of the miles. So I already did that too. So I called them C and D. They're calling them F. So they just wrote it with F and G instead of F and, or C and D. I like, if I am defining a function, I don't usually go with F and G unless it's just a generic function. If it's an application, I will probably name it something that's related to the application. It doesn't matter though. So we can also then go that this is this, which was what we came up with earlier. So we can actually get a function of time. And do you see how I inputted the f of t into the function? So that's how we're blending those two functions together. Okay. So true or false, the output quantity of function f is the input quantity for function g. So let's think about, okay, so the input for f is time, and it gives us miles. We put that into function g, and that gives us calories. So let's make a little chart to kind of tell us what's what, okay? So in our f function, I inputted time, I output miles. G, I output calories, okay? Okay, it says the output of function f, so let's highlight that. The output of function f is the input of function g. Yes, it is. So that's true. And then they want us to draw a little picture here. So the input of function f, so it's exactly what I drew up above in just that little machine looking way, which I love that machine thing. We are inputting time. We are getting out miles. We are inputting miles. We are getting out calories. Because it's a two-machine process, a two-step process. How many miles did she run? That's going to give us how many calories that she ran. And then it says define a function h that represents the number of calories c. So c is h of f, let's just call it h of t, which is f, which is g of f, which is g of f of t, which is g of 0.15 t, which is 110 times 0.15 t. So the only thing they're trying to get to into your brain for this particular lesson is that what function do you use first? That is our inner function. So in this case, it was our time, distance equals rate times time. And then we take that miles and change it into calories. So that's our miles. And if we multiply by 110, that becomes calories. So that's kind of what they were looking for there. Okay. So I do want to practice doing function composition for just generic functions, not ones that have lots of words with them. Okay. So now if we could just move on to number 3 with the table. So we're going to do table ones, we're going to do graph ones, and we're going to do just algebraic ones. Okay. So let's start with the table. And it says in 3a, we're going to find g of f of -1. So you just keep saying, just go in order, g of. So we're going to start with the inside. Now that's saying that our x value is -1. We're going to put it into the f function and we're going to get a y value. So let's go over to the chart. F of -1 is this right here. Wait, I'm sorry, this right here. F of -1 is when our x value is -1, our f of x value is 3. So now we know this is 3. So let's take this out and replace it with what we know it is. We know it's the number, you never make a G to look good, then we know that's the number 3. Okay, let's say it again. F of -1, when x is -1, our f value is 3. So that becomes 3. Now, it's done. We never use f again. Now we use the g function. If our x value in g is 3, our answer is 0. So do you see how we worked from the inside out? So let me write it so you can see it a little nicer. So we started with -1. We used the f function. It became 3. We put that into the g function and it became 0. See how that worked? Okay, let's do it one more time. -1 for our f function gives us a result of 3. 3 in our g function gives us an answer of 0. Our final answer is 0. Okay, let's do another one. We're going to start with the inside. We're going to put 3 on our g function. So if x is 3, our g function is 0. Now we're going to take that and use our f function. So if we go into the 0 and we use our f function, we get a value of 4. So this became f of 0, which is 4. Does everyone see how those connect with each other? You have to work from the inside out. Okay, let's do the next one. We're going to take 3. We're going to use our f function. So we're going to find an x value of 3. We're going to see what our f function value is. It's negative 2. So that is this inner piece. So now we have negative 2. Well, we have to use our f function again because we found that f of 3 gave us negative 2, but we still have an f there. So we have to use the f function one more time. So let's go over to the chart. If we find negative 2 as our x, if we go and find our f, it is 0. So our final answer is 0. Okay, so let's look again. If you look at 3 on our chart, the f value at 3 is negative 2. We're going to use the f function again. If we have an x value of negative 2, we get an f value of 0. So our final answer is 0. And then in D, we're going to use the 0 function twice. Okay. Or I'm sorry, the G function twice. So if I look on the chart, if I look at 0, G has a value of 2. So replace that inside stuff with 2. G of 0 is 2. Now it says find G of 2. So now we're going to go back to the chart. We're going to find an x value of 2, and we're going to use the G value again. So our final answer is negative 1. Now, when you are working from the inside out, just do that. Ignore the outer stuff, use the inside stuff, and keep peeling off the layers of the onion. Go from the inside out. But our E goes the opposite way. Okay, so this is what I think of for E. I am going to pretend that this isn't here. I'm going to say, where on my f function will I have a f of x value of 3? So we're going to go down this chart and look, where is our f value 3? It happens when x is negative 1. So this had to have been negative 1. So this has to be negative 1 for that to happen. But then we've got to go back on our chart and say, okay, when is g of x equal to negative 1? And that happens at an x value of 2. So this happens when our x value is 2. So if they said g of 0, take the x value of 0, look at what the g value is on the chart. If they say g of x equals something, you are finding this value and then the corresponding x, so you're going backwards on the chart. Does that make sense? A little. The looks on your face are great. So now let's actually practice using function composition with just normal functions. Okay, let's just practice, not with a table, but with a normal good old function. So please note that we could write this as f of g of 2. That is an alternate way to write that. Okay, this could be written as h of f of 61. No matter what, it means the exact same thing. Means exactly the same thing. Okay, let's start with this one. We're going to start with the inside, work our way outside. We're going to pretend that the f isn't even there. If I asked you to find g of 2, we know how functions work. That means to input 2 into this function. If I input 2 into that, don't I get 4 plus 9? Or I get the number 13. Okay. Now we can pretend that g was never in the problem. You know how to do this. How do you find f of 13? You input 13 into the f function. So if we look at our f function, that's this one. That will be the square root of 16 or 4. So go in layers. So let me go over what I did one more time. I plugged 2 into the g function. I got 13. I plugged 13 into the f function. I got the square root of 16 or 4. Work your way from the inside out. Okay. So in B, which function do I use first and what am I inputting? In B, what function do I use first and what's its input? Exactly. I use the f function first and I'm going to input 61. Now that would be the square root of 64, which I know is 8. So simplify things down as much as possible. Now we're going to take the h function and we're going to plug in 8. So that's just 8 divided by 4, or our answer is 2. Now, C is just saying, give us a general formula for M if we input the H function into G. So let's take our G function. Let's write down what H is. H is x over 4. So that's the input that we are going to use into our G function. So where our G function is sitting, look up here. That is our input. Where the x is sitting, take out x, put in x over 4. So that's just 2 times x over 4 plus 9. Now, can I do much with that? You can simplify it slightly. 2 and 4 are both divisible by 2. So our M function would be x over 2 plus 9. So they're just having you simplify when you compose those two things. Now, in part D, they're saying find P of x such that P of x is G of f. So this time, we are inputting the f function. So let's write the f function right here. The f function is the square root of x plus 3. What is it going to input into? It's going to input into the g function. Work your way from right to left, which is very unusual. We don't do that usually. If I input that into the g function, it's going to go right there. So that's going to be 2 times our input, square root of x plus 3, plus 9. That's your formula. I don't know what that's going to tell me, but it allows me to rewrite the composition as its own brand new formula. So g of f is equal to the formula 2 square root of x plus 3 plus 9. Okay? So that's all we're doing for this investigation. Turn it in now. And then please, if you could, open up your iMath. And I want you to open up homework M3.4. Click on question 4 for me. Homework M3.4, question 4. Okay, so the homework I think is listed on Saturday or Sunday in your calendar. Find homework M3.4. Click on question 4. We're going to do question 4 together. So go into your iMath. Find homework M3.4. Question 4 looks like this. Now, I don't know if your numbers and my numbers are the same. If they are, great. If they're not, please adjust accordingly. But we're going to do this question 4 together because I thought they didn't give a good example in the investigation. I wanted you to be able to do it with me. And if you ever come across a homework problem that just isn't like one we have done together, let me know. We can try to start doing them here and there together, okay? Okay, so in question 4, we have 2 functions. F is given in blue, it's the straight line. G is this parabola. And it says, evaluate the following composed functions for the given input. Okay. So let's talk about G of f of 1. Now again, please note, yours and mine, are they the same? They might be the same, they might be different. Okay, so let's look. So let's start here. What is f of 1? You're going to go over to the graph. You're going to find an x value of 1. If your number's different, use a different number. We're going to go up to the f function. The height there is our answer. That is 2. So g of f of 1 is really saying find g of 2. So now we go over to the x value of 2, but this time we go up to our red g function, and we get an answer of 4. See how that works? Similar to the table, okay? Let me show you one more time. F of 1 is 2. Why is that? Because for an x value of 1, our f height hits 2. G of 2 then, because that's equal to 2, we put a 2 there. That means if I have an x value of 2, what height does my g function hit? It hits a height of 4. That's my answer. Okay, let's do this one. This time we're starting with our g function. We find an x value of 1 and we go up to our g function. G of 1 is 1. So that's really saying f of g of 1 is really just f of 1. So now I'm going to go back, find an x value of 1, go up to my f function. The number is 2. My final answer is 2. And then let me do the f function twice. Yes. I'll come and look. Okay, then let's look at C. If we go to 2.5, go up to the f function, I would say it's probably, let's go 3.5. So this here is 3.5. Now we go to the f function again at 3.5, and I think the answer is probably 4.5. So that hopefully will help you with that particular question. Okay, now stay in iMath. I want you to look at homework 3.7, question number 8. Homework 3.7, question number 8. Okay, so homework 3.7, question 8, f of x equals 1 over x. They asked you to find the difference quotient for that. Is that what your question 8 looks like? Is that what it says for question 8? Okay. I want to show you how to do this because we did not do a fraction one in our notes. I wanted to do this. You'll notice that you do not have to do question 9 and 10, just question 8, okay? Let's do question 8 together. So they've given us f of x. So let's write down what is f of x plus h. It is 1 over x plus h. Okay? Now, these are ones where I would suggest when you do the difference quotient, have a sheet of paper or a little sheet of notability paper that you can write on, okay? So remember our formula is f of x plus h minus f of x all over h. Excuse me. Let's plop these things into the formula. We get 1 over x plus h minus 1 over x all over h. Now, if you go to put that into Desmos, not Desmos, I'm sorry, if you go to put that into iMath, it's probably going to say no, because they want you to cancel out the h. Remember I told you that all difference quotients can cancel out their h's. So I'm going to show you how to do that, okay? You're going to, anytime you end up with this fraction within a fraction, this is always the hint that I will give you, whether you're sitting in my pre-calc or in a calculus class. Surround the top and the bottom by parentheses. And we're going to multiply top and bottom by both of the denominators that we see. Okay. On the bottom, we are not going to do the multiplication. The reason we're not going to do the multiplication is we want the h to cancel, okay? But we are going to do the multiplication on top. Watch what happens. If we multiply this, it actually just sits by the 1. So what section cancels? If this goes and sits by the 1, what part of the fraction cancels? The x plus h. What's left? X. Okay, let's write what's left. Now there's a minus symbol. Now let's do the same thing here. If we multiply here, what cancels? This time, if it's sitting on the 1, this time what cancels if we multiply this here? The x's cancel, right? What's left? X plus h. Now, I told you never to do anything to simplify the bottom, and that's the case for these. These bottoms can be really confusing. Leave it. But the tops definitely simplify. So if I distribute the negative, watch what happens. I get x minus h. What happens to the two x's? They cancel. And so we're left with negative h over h times x plus h times x. Can we cancel out the h's now? Sure can. What is negative h divided by positive h? Negative 2 divided by positive 2 is negative 1. Negative 3 divided by positive 3, negative 1. Negative h divided by positive h is negative 1. So your final answer for this question in iMath would be negative 1 over x plus h times x. So that's question 8. The other ones were 9 and 10 were actually harder than this one. I think I did one of them up there on the board earlier, but that is question 8. This is your final answer for iMath. Okay. Now, after you enter that, please could we go to today's pre-course that is due 3-4. Please go to pre-class 3-4. Okay, so the answer you wanted was right there. Please go at this time to pre-class M3.4. Okay, we're going to do this together so that you can just have this turned in. Okay. It says, so this is pre-class M3.4, today's assignment if you go into the calendar. It says, let's consider a situation in which you are planning your summer road trip and you want to estimate the total fuel cost given the distance of trip in miles to and from the destination. For this situation, the independent quantity should be how many miles did I go? The output would be the total cost of the fuel. So I kind of thought of it like this. How many miles will dictate how much the total cost will be. And then it says, what other information will you need to determine the total fuel cost of a trip in dollars in terms of the distance and miles of the trip? Well, you need to know the gas mileage. You need to know how much your fuel is actually going to cost. And then maybe this one, the number of miles that you spend traveling. Oh, it's just the first two? Okay, don't worry about that. Oh, yeah, because the gas mileage would account for the hours and all that. Yeah. Okay. So that's what you need for that one. And now let's jump to, now they've given us more information. They told us that the fuel costs $2.80 per gallon, that your car gets 32 miles to the gallon. And then it says we're going to call F is going to determine the number of gallons of fuel consumed on the trip, and V, or what we call that V, given the total distance D of the trip. Okay. So what I started with was I thought of the fact that if I drove 32 miles and I'm getting 32 miles per gallon, that would take me 1 gallon, right? If I drove 64 divided by 32, I'd need 2 gallons of gas and so on. So I think what they're trying to get here is that for us to be able to figure out how many total gallons we need, that we have to divide that D value by 32. So that's what they want there. And then for this next one, they said, if we know how many gallons we're using, so I think they made a use V for volume, I don't know. If we know how many gallons we're using, every gallon of gas costs 280. So the cost would be to multiply the gallons or the volume by 280. So I think that's where that came from. But what they're going to want us to do is, look, we want a function of that we blend those two things together. So see, the V is D divided by 32. So we want to first have our F function be D divided by 32. Our G function is 280V. So if we put them together, our G of F of D, let's put these two functions together. It would be 280 times D divided by 32. So that's our function. And I don't think there's anything else you have to enter for that. But they're just trying to show you how those things can go together to give you what you want. It's a two-step process, and that's what composition of function is. We have to do the how many miles or how many gallons do we need first, and then multiply by the price per gallon. And so it's just that two-step process is what function compositions are all about. So hopefully that's done. You do actually have a little bit of time. Start looking at the homeworks that we have started. Monday you did 3-3. Yesterday we did 3-7. Today we did 3-4. So right now, focus on the 3-3, 3-7, and 3-4 homeworks. Those are the ones that are due on Sunday, I believe. Okay, so start working on those.